Hello learners, welcome back to Constant Learners. Today we're discussing the various database development methodologies with loads and loads of examples. But before that, if you're new here, don't forget to subscribe to the channel for more educational content. Now, prior to understanding the different approaches to build the databases, let's understand why planning is crucial in database development. Imagine you're building a house. If you directly start placing the bricks without a proper blueprint, the house might collapse. Similarly, if you start creating tables in a database without planning its structure, you'll end up with a messy and inefficient system. Building a database involves designing and implementing its structure based on specific requirements. The approach chosen depends on factors such as data complexity, scalability, and application needs. A well-designed database improves performance, ensures data integrity, and makes future modifications easier. Now let's dive into the different ways we can design a database. Now, no matter which approach you choose, database design usually happens in 3 stages. These are not the approaches for database development. These are just the 3 stages that are usually used in every approach, right? So they are conceptual design, logical design, and physical design. Now, all the database design approaches uses these 3 design stages just in different sequence and formats. So let's first understand these 3 key phases of database development, and then we will discuss the different approaches in developing the databases. First one, conceptual design. This is the initial planning stage where we create a high-level design of the database without worrying about the technical details. Now, what is a high-level design? See, entity relationship diagrams, wherein we define the entities, attributes, and their relationships. This we've already discussed while discussing the ER models, while learning about the different data models. Let's say, for example, if we are building a university database, we will identify the entities like students, courses, professors. These are the entities. Let's say for the attributes of the student's entity, we'll take the student's name, course ID, professor name, right? So in the conceptual designing stage, we are identifying the entities, the attributes, and the relationship between the entities. See, you need to understand that these are not the actual tables. These are just the entities, the designing stage. If you don't understand this, make sure to check out the video on the data models. Now let's head to the next one, that is logical design. In the logical design, we convert the conceptual model into a structured format, right? That can be implemented in a database. So in the logical design, we define the tables, we define the keys like primary key, foreign key, candidate key, etc. Right? So all of this happens in the logical design. Let's continue with our example. So here we have the entity students. In this case, that is in the logical designing, we are going to build the students table, and the attributes will be student ID, name, age. Attributes means the columns that we'll have will be student ID, name, age, right? Then for the entity courses, we are going to build the courses table and define the attributes and build the relationship between all of these tables. Alright, I hope that this was clear. So that is the logical design, that is converting the conceptual design into actual tables and the columns inside the tables along with the keys and the relationship between the tables, right? Next is the physical design. Now, physical design is the final step where we decide how the database will be physically stored and optimized. It includes indexing, partitioning, and performance tuning. For example, choosing whether to store the data using B trees, hash indexing, or clustering for faster searches. Now we've discussed conceptual and logical designs in detail in previous videos. Physical designing portion will be discussed in detail in the future videos. I hope that you've understood what is a conceptual design, logical design and physical design. Now that we've understood these phases, let's move on to the different database development approaches. Now there are multiple ways to build a database and each approach is suitable for different scenarios. We are going to discuss 19 approaches in this video and thus we need to be quick, right? And in the end, I will explain how you must remember these from a university exam or an interview point of view. All right, let's go through them one by one. All right, so the first one is the top-down approach. In this method, we start with a broad overview of the system and then break it down into smaller, more detailed parts. Let's say if you're designing a hospital management system, then we first define a general schema in case of top-down approach. All right. In case of top-down approach, we first define a general schema. Then we include the entities like patients, doctors, appointments, billing, etc. And then finally break it into specific tables and attributes. So in the top-down approach, we start with a high-level conceptual model. That is an ER diagram. In that, first we define the entities, relationships and constraints. Then we progress to logical and physical schema design. This is best for large systems like banking, ERP and university databases. So that was top-down approach. Next, let's head to the bottom-up approach. Here we start with the smallest data elements and then combine them to form a structured database. Let's say we have raw customer records in Excel. So we first create separate tables for the customers, products and transactions and then define the relationships between them. Alright, so the bottom-up approach starts by designing individual components like tables, attributes, etc. Then we gradually integrate them into a complete database structure. Alright, this is best for smaller databases that evolve over time. That is when integrating existing data like spreadsheets into a relational database. Next one is the inside-out approach. Now, instead of starting from a broad model, we begin by designing the most important core data first and then we build outward, right? For an example, let's say in an e-commerce database, we might first create the customers table, only the customers table, and later add tables for orders, payments, and reviews, right? So we are starting with the core data first, and then we are building the rest of the things that is surrounding the core, the most important data. So this focuses on key entities first, defining their attributes and relationships. So not just the entity, we are also defining the attributes and the relationships. And then we expand it by adding related entities and refining the relationships. See, first we've built the core data. We've also built the attributes and the relationships with all the other entities that are going to be connected to this core entity, right? But when we build the other related entities, we refine the relationships. Alright, this is best for databases with core functional requirements like retail, inventory, and logistics systems. Next one is the hybrid or mixed approach. This is a combination of top-down and bottom-up approaches, allowing for flexibility while maintaining the structure. For example, if you're developing an HR system, we might use the top-down approach for defining employee details, but use the bottom-up approach for payroll integration. So we are using different approaches for different sections of the database, right? So it starts with a general design and integrates smaller components. This is best for large and complex databases requiring flexibility, planning, and adaptability like ERP and e-commerce platforms. Now, e-commerce and ERP have come in the previous approaches also, right? So, different approaches can be used for the same purpose, right? But it depends upon the database designer and the database requirements. That is, which approach will be best suited to build that kind of database, right? Now, next one is the incremental approach. In this, the database is built and deployed in small incremental stages or modules rather than designing everything at once. For example, a startup launching a food delivery app might first implement a simple user database and later add features like restaurant reviews and payment history. So it is built and deployed in small incremental stages. That is, first they've built the basic app for ordering food, right? And then later on they have added the review section, the comments section, etc. So each module is designed, tested, and then expanded. It is best for agile development and systems with evolving requirements. Next one is the centralized approach. In this, all the data is stored in a single database, typically on one server. For example, a university database where all student records, courses, and faculty details are stored in a central location. It provides high consistency but may lead to scalability issues because everything is on one server and it's not necessary that there will always be space to expand the data. Right? This is best for small scale applications needing strict control like banks, government records, enterprise applications, etc. Next one is the distributed approach. Again, in this case, the data is distributed across multiple locations, often in different servers or geographic regions. For example, a global e-commerce company like Amazon, where user data is stored in multiple data centers worldwide, right? So the database in this case is spread across multiple locations, and since the data is stored at multiple different locations, at multiple different geographic locations on different servers, there are high chances that the data is replicated or partitioned, that is divided for better performance. This is best for large geographically spread applications, cloud applications, multinational companies, content delivery networks, etc. Alright, next one is fact-based approach. In this case, the database is designed using facts and relationships with a focus on data modeling rather than predefined table structures. For example, a NoSQL database using graphs and key value pairs instead of traditional relational databases, right? So this design is based on facts and relationships. It is mainly focused on data modeling, right? There's no predefined structure in this case. The structure depends upon the type of data that we are storing in the database, right? It is commonly used in data warehousing and NoSQL databases. So data warehousing as well as NoSQL databases will come in the future videos. This is best for data analytics, AI-driven insights, graph-based databases, big data, and business intelligence. Next is file-based approach. In this case, as the name suggests, the data is stored in files rather than databases with simple storage formats like CSV, XML, or JSON. We've discussed the file processing system in the previous video. You can watch that video for more information. A small business using Excel spreadsheets for inventory tracking, right? This is an example of file-based approach. So this stores data in flat files with no relationships. This is a drawback of file-based approach, that there's no relationship between two files. We cannot link the data from one place to another. So that is the limitation, that is redundancy, lack of structure, and inefficiency. There's going to be repetitive data in multiple different files. This is best for small scale applications, log storage, temporary data storage. Next one is the manual database approach. In this case, data is stored in physical records, books or registers instead of a computerized system. For example, hospitals keeping paper-based patient records in folders. So this approach uses physical records, spreadsheets or simple tables before implementing a database management system. That is the manual database approach. It is best for small businesses, historical data storage and non-digital environments. Next approach is the relational database approach. It uses structured data. We've already studied relational databases, relational model. So this uses structured tables with predefined relationships between data entities. For example, a banking system where customer accounts, transactions and loans are linked through foreign keys. We've already discussed all of this in detail. It uses keys and normalization to maintain data integrity. We've also discussed keys, different types of keys, types of normalization techniques and data integrity as well. This is best for business applications, enterprise systems, transactional databases. Next up is NoSQL or non-relational database approach. It uses flexible schema-less structures like key value pairs, documents or graphs instead of tables. So it depends upon what kind of data we are storing. Social media platforms like Facebook, where user data is stored in document-based databases like MongoDB. It is mainly used for unstructured or semi-structured data because it has no fixed schema. It is designed for scalability and flexibility. It is best for big data, real-time applications and high-traffic websites. Next up is cloud-based database approach. Here the databases are hosted and managed in the cloud instead of local servers. For example, Google Drive or AWS DynamoDB, where users access data from anywhere via the internet. So the data is stored on the cloud at multiple different locations. That is why we are able to access the data from anywhere around the world. Amazon, everyone around the world is using Amazon because it is available on the cloud instead of local servers. So in this case, databases hosted on cloud platforms for scalability and easy maintenance. It is best for remote teams, scalable applications and cost-effective storage. Next up is data warehousing approach. This is a specialized database designed for analytical queries and reporting rather than daily transactions. For example, a retail company analyzing sales trends using Amazon Redshift or Google BigQuery. We'll discuss this in future videos. So this is like data warehousing approach is mainly designed for analytical processing, integrating data from multiple sources, right? And then using that for incrementing our businesses, for helping the businesses to expand using the available data. It is best for business intelligence reporting and historical data analysis. Next up is AI-driven database approach. This uses AI and machine learning to optimize performance, automate indexing, and predict data trends. Google Cloud Spanner uses AI to optimize database queries and automatically adjust the resources. It is best for predictive analytics, automated decision making, and intelligent data management. It is entirely AI driven and thus using machine learning approaches to make everything automated. Next up is prototyping approach. Here we build a small working model of the database, get feedback and refine it step by step. The name itself says that it is the prototyping approach, right? When we are building a prototype, we build something, we get the feedback and then we refine it according to the requirements. For example, a startup developing a food delivery app may first create a simple version with only customer and restaurant details and then gradually add features like tracking and reviews. This is best for startups and fast changing applications. Next up is the waterfall approach. This is a linear step-by-step method where each phase is completed before moving to the next. For example, a government project like a national ID database must be carefully planned and executed in strict phases without changes, right? So this is a linear method because here everything has to be perfect, right? First, we complete the first step, then only we move on to the next one, right? This is best for stable large-scale projects with fixed requirements. The 18th approach is the Agile approach. This method focuses on flexibility and continuous improvements with small iterative updates. A social media app may start with a basic user database, then continuously add features like likes, comments, and messaging based on user feedback. So if we look a few years back at the Facebook or the Instagram or the YouTube apps, how they were earlier and how they have evolved over time, it is really commendable, right? So this is the Agile approach where they build something, they make it available to the audience, and then they continuously keep on improving it as per the user requirement. This is best for dynamic applications like mobile apps. And finally, the last one is the DevOps approach. This integrates database development with continuous monitoring and automation. For example, a stock trading platform needs real-time updates and automated backups, making DevOps an ideal approach. It is best for cloud-based applications and real-time databases. Now, the choice of approach depends on the database size, complexity, scalability, and application requirements. Alright, so those were the approaches to database development. Now, the choice of approach depends on the database size, complexity, scalability, and application requirement. Right? A well-planned approach ensures efficient data storage, retrieval, and security, making the database scalable and maintainable. Now, if you are using this for exams point of view, then it is important that you remember the names of at least 12 to 13 approaches. Then, depending upon for how many marks the question is, you need to explain 2 or 4 or 6 approaches in detail, and for the rest of the approaches you need to just write the names of the approaches, right? So that the examiner will know that you know the answer, you know the content. And if you're preparing for the interview point of view, then it's important that you remember the names and examples, because if you know the examples, then you can easily explain where this particular approach can be useful or how this approach actually works. Alright, so that was all for this video. If you like the video, don't forget to give it a thumbs up, subscribe to the channel, and thank you so much for watching. If you have any doubts, any queries, don't forget to write them in the comment section below. See you in the next video.